So you guys can do these whatever colors you guys want. Just my suggestion is, if you guys did highlight the pi over 4s one color, to not use the same color for what you're about to do. So altogether, you guys should have 3 different colors to highlight the different types of angles along the unit circle. So for myself, the first angle in each quadrant, I shouldn't say each quadrant. Let's start with quadrant 1. This angle right here is how many degrees? 30 degrees. So think about this as a radius. It's going to go all the way through the origin and through the other side. I'm going to highlight this in blue. And then in this quadrant, going backwards in the negative direction, the first angle off the x-axis would be this angle right here. I'm going to highlight this one in blue, and then go all the way across to the other side of the circle. So we know that this angle right here is 30 degrees. 30 degrees, guys, if you guys don't know this by now, please know this by class Wednesday. What is that in radians? Pi over 6. Okay, so according to our notes, we figured out, remember, x is what? Sine or cosine? Cosine, and y is sine. According to our notes, what was the cosine of 30 degrees in the last problem we just did? Square root 3 over 2. So this is square root 3 over 2. And the sine is y. What was that? 1/2? Okay. Remember, on the outside, we're going to put the tangents. What was the tangent of this angle, according to our notes? Square root 3 over 3. Good. Cool. Now, all these follow a special pattern. So the reason why we're highlighting all of them is because just like for pi over 4, the answers are going to be really similar. The only thing that's going to change is the signs, not this sign. Sign like positive or negative because of where you're at on the graph. Okay? So if I'm now over here, okay, how many degrees is right here? So let's think about it. How many degrees is half the circle? 180. So do you guys agree that this distance is 30 degrees? So basically, if this is 180, I'm going 30 degrees backwards. So what's 180 minus 30? 150. So this would be 150 degrees, which is what in radians? Does anybody know? 5 pi over 6. Okay? So right here, if this is the 30 degree angle, I put it in quotes because this is how I want you guys to think about it. If this is the 30 degree angle in quadrant 2, it's going to be the same numbers. The only thing I have to think about is in quadrant 2, which one of these is negative, x or y? X. So it's going to be the same numbers, but it's going to be negative root 3 over 2, comma, positive 1/2. Does that make sense? All right, and then tangent. Remember, tangent is y over x. So it's going to be the same number, but we have to think about what's a positive divided by a negative. Negative. So the tangent is going to be negative square root 3 over 3. Okay, for following this pattern, we know this is 180, right? That means I'm going to add 30 degrees to that angle to get to this angle. So what would be 180 plus 30? 210. So notice that this has a pi over 6, and so does this has a pi over 6. This angle will also have a pi over 6. How many? 7. Good. So this is 7 pi over 6. So same numbers, but what do we know about numbers in quadrant 3? They're both negative. So it's going to be negative root 3 over 2, comma, negative 1/2. And then tangent is y over x, but a negative divided by a negative gives me a positive. Okay. Quadrant 4. How many degrees is this angle right here all the way around? 360. So I'm going 360, but to get to here, I'm going to go backwards 30 degrees. So this would be 330. Our favorite time of the day, because that means it's almost time to go home. This is going to be a pi over 6. How many? 11. Good. All right. What do we know about numbers in this quadrant? Which one's negative? Y. So it's going to be root 3 over 2, comma, negative 1/2. A negative divided by a positive gives me a negative. So the tangent's going to be negative root 3 over 3. Okay, questions on where those came from? All right, so now we're going to highlight all the pi over 3s. So these angles, I want you guys to think about, these are the ones closest to the x-axis. The ones that we're going to highlight now are all the angles that are closest to the y-axis. So I'm going to highlight those in green. So this is 30. What was this? 45. What is this? 60. $60 degrees was what in radians? Pi over 3? Is everybody cool with that? What's nice about 60 degrees is it's the same numbers. What's the only thing that happens? They switch. So going all the way around the unit circle, all the pi over 3s are going to be the same coordinate points, just they trade places. So instead, it's going to be cosine of 60 degrees is 1/2, and the sine of 60 degrees is root 3 over 2. Okay? Now, according to our notes, what was the tangent when I did that? Square root 3. So tangent's going to be square root 3. Cool. This is the easy part. The hard part's what's going to come next for you guys is memorizing all this. Okay? Right here. How many degrees is this? 120. This is also a pi over 3, but what number goes in the front? 2. So this is 2 pi over 3. All right. Since I know it's going to be the same numbers as over here, the only thing that's going to change is that x is going to become negative. So it's going to be negative 1/2, comma, positive root 3 over 2. And tangent's going to be negative. Okay. Is everyone good there? This is 270 degrees. So this distance right here is 30 degrees. So if I'm going backwards 30 degrees, that's going to give me how many degrees? 240. This is also going to be a pi over 3. What number is going to go in the front? 4. Good. So this is going to give me negative 1/2, negative root 3 over 2, and then positive root 3. What angle's here? 300. And then that's going to be 5 pi over 3. In this quadrant, x is positive, so it's going to be 1/2 negative root 3 over 2, negative square root 3. Okay, cool. How are we doing? Do we hate this? Trust me, by doing these problems over and over and over again, you guys will memorize these. Just trust me, it'll happen. Whether you guys are not wanting to learn it or not, you'll learn it. So this is my homework. That's not really your homework, but you guys should be doing this. You guys now have basically everything filled out. What I want you guys to do on your own time is transfer all this information onto your big unit circle. So I can post mine so you guys can check. Or, oh no, I didn't yet. I did not post it yet. Oh yeah, it's already posted. So this is what your unit circle should look like. The only thing that is not on here is what? Compared to yours, the tangents. That's something that I changed this year is I added the tangents so that way you guys memorize them too. So what I could do is I could repost this for you guys. But I could add the tangents too, so that way you guys have them. But what I want you guys to notice is that there are some patterns to this. So I want you guys to all look up here. The first coordinate is what? Sine or cosine? Cosine. So if I start right here, I want you guys to look at the pattern. It goes 1, 3, 2, 1, 0. So what I want you guys to think about is why is this a 1? What am I doing? Not a timer. Annotate. So I could do this to this number, right? And it won't change it. I could do this to this number. If I want this to be a 1, do you guys see how this is square root 2, square root 3? I can think about this one as square root of 4. Because what is the square root of 4? 2. What's 2 divided by 2? 1. So this one starts at 1 and then goes 3, 2, 1, 0. Sine goes 0, 1, 2, 3, and then the top's 1. So they flip, okay? So that's one pattern you guys can notice. You really only need the first quadrant memorized because if you have these memorized, like I said, pi over 3, you just have to know, okay, well, 2 pi over 3, that's quadrant 2. It's the same numbers, but just remember in quadrant 2, which one's positive, which one's negative, okay? If you have the first quadrant memorized, you can figure out anything, okay? I promise. Because that's how I survived trigonometry when I was in your shoes, okay? My teacher didn't force us to memorize it, but when I was in college, we couldn't use a calculator, so I was kind of screwed. And I had to memorize it after that. So if you guys know the first quadrant, just trust me, the rest of this will follow, okay? So this is being recorded for our friends at home. But Tuesday, when you guys have your first trig quiz, you guys are going to be given a blank one of these, and it will be timed. You have to fill out everything, including the angles. You must know the angles and all the coordinate points. Altogether, it adds up to like 51 points, okay, if you know everything, okay? So, that being said, I can print more if I need to print more, but in the corner of my classroom by the microwave, underneath the paper towels, there are a bunch of blank unit circles. If you guys want to take some copies, that way you guys can practice filling it out. And my students in my regular pre-cal class were timing themselves because for them, I gave them 7 minutes. For you guys, I'm gonna give you guys 6 minutes to do everything because you guys are college, okay? You guys got this. The record is under 3 minutes. So let's see if one of you guys can beat the record. Last year, one of my students in my Math 3 honors class filled everything out in like 2 minutes and like 40 seconds. Cool? All right. Questions on this? I'll post a new one today with the tangents. Okay, so let's move on. Okay. Which quadrant am I in? Quadrant 3. Okay, so quadrant 3. What I want you guys to think about is, remember I told you guys we just really need to have the first quadrant memorized? Where is 210 degrees? We know it's in quadrant 3, but if I'm right here, how many degrees is this? 180. So how many more degrees do I need to go? 30. So what I want you guys to think about is this angle right here would be so instead of having to memorize this one, remember this is going to correspond to the same angle in quadrant 1 that's 30 degrees. Does that make sense? Because they're both 30 degrees off of the x-axis. So if you guys are taking my advice, then if you memorize this, that the point here would be root 3 over 2 comma 1/2, which one is cosine, x or y? X. So we care about the x, okay? So it's gonna be the same numbers here. What's the only difference if I'm down here? It's negative, right? So the points here would be negative root 3 over 2 comma negative 1/2. So this answer is negative root 3 over 2. Okay, to show your work for this, you don't have to draw a picture. This is just me showing you guys how you guys can think about it if you get stuck. Okay. Trying to make my circle look better, whatever. Where is this? Quadrant 4? Because if I'm going negative, remember I'm going this way. So negative 60 degrees in this direction is going to look something like this. So this is what I want you guys to think about. We're thinking about whatever angle is negative 60 degrees in this direction, but do you guys agree that this distance is still 60 degrees? Okay, so instead of memorizing this point, if we know what the 60 degree angle is in this quadrant, then it's going to help us out. So what are the x and y right here? 1/2 comma square root 3 over 2. Okay, so since we're wanting sine, which one do we care about? The y. What do we know about y in this quadrant? It's negative. So the point would be 1/2 comma negative root 3 over 2. So the exact value of this is going to be negative square root 3 over 2. Now, I wanted to emphasize this so you guys don't do this on your homework. If it says exact, one way I know for sure that you guys use a calculator is if you guys just type this in, it's going to give you a decimal. Okay, it wants the radical, so do not type in a decimal for something like this. Okay, part C. Okay, so in radians, what you're really kind of focused on is the pi over 3 part. Okay, so let's say you guys don't have your angles memorized yet. I need you guys to at least know what pi over 3 is. Pi over 3 is the same thing as how many degrees? 60. So the way you guys can think about it is it's 5 times 60. What's 5 times 60? 300. So this is the same thing as the tangent of 300 degrees. Is everybody with me on that? Does that make sense? So which quadrant would this be in? Quadrant 4, good. So in quadrant 4, what I'm doing is drawing an angle, or drawing our angle so it finishes in quadrant 4. So this is gonna give me 90 degrees, 180 degrees, 270 degrees. How many more degrees do I need to go? 30 more? Okay. So the way to figure out what I should use is, if this right here, this little distance right here is 30 degrees, do you guys agree this distance would be 60? Okay, so I'm thinking about, again, which angle corresponds to the 60 degree angle in this quadrant is going to be the same thing as the 60 degree points in this quadrant. Because this distance right here is what we call a reference angle. It's if we know some information about this angle right here, it's going to help me figure out this one. So it's the same problem as the last problem. We know this is 1/2, comma root 3 over 2. But we're looking for tangent. So how do I find tangent? Y over x. So it'd be root 3 over 2 divided by 1/2. Which is square root 3. But what do we know about tangent in this quadrant? It's going to be negative because it's going to be a negative divided by positive. So it's going to be negative square root 3. All right, let's do a hard one and then we'll move on. D. Okay, is 8 pi over 3, is that one of my angles on my unit circle? It's not. Okay, so it's a little bit bigger. So what we have to remember is we learned something about coterminal angles. Do you guys remember? That's angles if I add or subtract 2 pi to the angle, it's going to give me the same answer. Does that sound familiar from last week? Okay, so this angle, do you guys agree then is too big to be on my unit circle? So to figure out what angle is going to give me the same answer, since this is too big, I can subtract 2 pi to help me solve this problem. So 8 pi over 3 minus 2 pi is the same thing as 8 pi over 3 minus, if I get a common denominator, do you guys agree I can multiply top and bottom by 3? So that will give me 6 pi over 3. 8 pi over 3 minus 6 pi over 3 is going to give me 2 pi over 3. So that means that this angle and this angle are coterminal, they land on the same spot on the unit circle. So remember, pi over 3 is the same thing as how many degrees? 60. What's 60 times 2? 120. So this is going to give me the same answer as the cosine of 120 degrees. Okay. So 90 plus 30 is 120. Okay, so that means I'm right here on the unit circle. Okay, but since we know this is a pi over 3, that means if I know my pi over 3 in this quadrant, all I have to do is apply the correct sign to get the answer. So again, what's the x and y right here? 1/2, comma, square root 3 over 2. Which one do I care about if I care about cosine? X. Since I'm over here, what do you know about cosine over here? It's negative. So this is going to give me negative 1/2. Okay. So some of you guys, I'm not going to lie, you guys look very unimpressed right now. This is assuming you guys don't have your notes and everything in front of you. I'm trying to show you guys how to think your way through it if you guys don't have it memorized. Okay? All right, questions? All right, the next example you guys should like because we can finally use a calculator. So please take it out. Okay. Believe it or not, these problems are missed all the time because something is important to pay attention to in this problem. You guys have learned about angles and two different types of angles. What is this symbol right here? Degrees. So your calculator has two modes. It has radian mode and it has degree mode. Since it's asking you to find the cosine of 48 degrees, your calculator must be in degree mode. So to make sure it's in degree mode, underneath the alpha button, oh no, just kidding. To the right of the second button, there's a button that says mode. Click on that, and then there should be one of the first options that says either radians or degrees. Make sure it's in degree mode for this problem. Everyone know how to find that? Everyone cool with that? So go ahead and go back to the calculation screen and type in cosine of 48. And if we round to two places, does somebody want to tell me what they get? Yes, 0.67. And that's all you have to do. Was your guys' calculators in radian mode or degree mode? It was in degree mode already? Okay. I can't remember if you reset it or not, which one it automatically switches back to. So, okay. All right, here's a cool one. Question. Do we have a cosecant button on our calculator? Okay, everyone look at the screen. You guys do have a button that says this though, right? Do not use that button. That means sine inverse, which you guys will learn in the next chapter. That is not the same thing as what you're thinking. Because we know something about cosecant, right? And sine. What's the relationship? They are reciprocals. Okay, so don't use this button. This is the same thing as 1 over the sine of 21 degrees. Do you guys agree? So I would use your fraction button, alpha x, and then type it in just like I wrote on the screen. And what do we get? 2.79. Cool. Okay. Questions? All right. C. The tangent of 5 pi over 12. Now, notice that there's no degree symbol. If there is no degree symbol, automatically assume it's in radians. Okay? Another way that you guys can assume it's in radians is if there's a pi. Okay, so no degree symbol and or a pi in the number, that means radian mode. So now go back to your calculator and switch your calculator now to radian mode. Okay, then hopefully you know where the pi button is. It's a second caret. And if we type that in, what do we get, guys? 3.773. Good. Okay, questions on that? All right. One more just for fun. Okay. Now, everybody listen, because this happens every year. What's the difference between this number and this number? There's no pi. Okay. Also, this is a fraction. You guys could have said that too, but there's no pi. Okay. So listen, if there's no pi, don't type in pi. This is telling you to use radian mode. That's all this is here for. So do I have a secant button on my calculator? But what do I have? Cosine. So this is the same thing as 1 over the cosine of just 2. And to 2 places. You guys get this? No? Oh, you know why? Guess what? Mine's in degree mode. Huh. 1 over the cosine of 2. At least I know you guys are paying attention. Do you guys get this? Okay. All right, questions? All right. I know these notes are long. This is the last problem, I promise. We saved the most important problem for the last problem. So this idea is going to carry over to the next section and also a little bit into chapter 3. Okay? So, find the exact values of the 6 trig functions of an angle theta if the point 4, negative 3 is a point on the terminal side of theta in standard position. Now, thinking back right now as I'm writing the directions for this, if you guys took Math 3 with me or Mr. Nickel last year, you guys have actually already seen this type of problem. The only difference is in this class, you guys will learn something cool to help kind of like check your answers at the end. And you guys will learn that starting Wednesday. Okay, so first thing we have to do is this point right here. Which quadrant is that point in? Quadrant 4. So we need to draw a radius in quadrant 4. Like this. It doesn't matter. You don't have to use graph paper, even though it gives you a point. Don't feel like it has to be perfect. Okay. And then from here, what I'm going to do is at this point right here, I'm going to draw a line that goes straight up to the x-axis to form a right triangle. Okay. This distance right here is my radius. This distance right here, remember our point was 4, -3. Do you guys agree this is the x? So that means I went this way, 4 to the right. So this is +4. This right here means I went down. The y value is -3, so this side of my triangle is -3. So most importantly, this means that this is theta. Okay? So it's always, theta is going to always be the angle closest to the origin when we do these. Okay, not this one, this one. Okay, so to find this side, I can use Pythagorean theorem. So what's different here is, technically it's a squared plus b squared equals c squared, right? But this distance right here was what, x or y? X. So I'm going to say x squared plus y squared is equal to r squared. So x was 4 plus y was -3 squared is equal to r squared. What's 4 squared? 16 plus. Guys, we're in pre-cal. Please don't make these rookie mistakes. A negative squared always gives me a positive. What's 3 squared? 9. 16 plus 9? Square root both sides. Technically, do you guys agree it should be plus or minus? Okay, but the radius, whenever we do these problems, distance should always be positive. So because it's a radius, we don't care about the negative. So it's just going to be 5. This is important that it stays as negative because it's where we are on the coordinate plane. This -3 tells me we went down. Okay, but this distance, the diagonal distance, should always be positive. Okay, so now I know this is 5. Yay. So now all I have to do is SOHCAHTOA. And then that's my answer. Cool. So sine of theta. Sine, remember, is opposite over hypotenuse. So do you guys agree it's going to be -3/5? Yes? Okay. Cosine is adjacent over hypotenuse. So what is it going to be, guys? 4/5. Tangent is opposite over adjacent. Yikes. So what's it going to be? -3/4. Good. To get the other 3, what's the only thing I have to do to these answers? Flip them upside down. Okay, so sine, the reciprocal of sine is called cosecant. So if I flip it upside down, I'm going to get -5/3. Secant is going to give me 5/4. And cotangent is going to give me -4/3.